In this next example, we're trying to find y prime of this equation where we cannot easily solve for y in terms of x. So let's come up with a game plan before we start to find the derivative. The first thing I look at is the left side of my equation, and I see a product of two functions. On the right side, I see a composition, tangent being my outer function. My inner function is actually a product rule of x and y. So now that I know which rules I'm going to use to differentiate, I will differentiate using implicit differentiation with respect to x. So product rule on the left side, the derivative of x cubed with respect to x is 3x squared multiplied by y plus x cubed multiplied by the derivative of y with respect to x, y prime, equals, now what's the derivative of tangent? That is secant squared of whatever's inside it, multiplied by chain rule, the derivative of x, I'm sorry, not chain rule, chain rule, which within it is a product rule. Well, what's the derivative of x with respect to x? It's 1 multiplied by y, adding the derivative, or x, multiplied by the derivative of y with respect to x, which is y prime. So now that I've taken the derivative, I need to isolate y prime. So before I can try to move this term that has my y prime around, I need to first simplify this side by distributing secant squared of xy. So I have 3x squared y plus x cubed y prime equals y secant squared xy plus xy prime secant squared xy. So now that I've broken this up into 4 separate terms, I can move different ones around easily. So first, this term and this term both have y prime. So I'm going to move this term over to this side by subtracting, and then this term that does not have a y prime, I'll move over here. So first, let's get these two to one side. So first it's y prime, and the first term is x cubed, and I'm subtracting this term, x secant squared xy. Oops, I wrote yx, but excuse me. Notice that I jumped a step and I went ahead and factored out y prime as my GCF. So on this side, I'm left with y secant squared xy. I don't know why I keep on writing yx. Commutative property makes it still okay, but normally it's alphabetical order. And then that will be subtracting this term minus 3x squared y. So now my last step is to solve for y prime, which was called dy dx in the problem, so I'm going to go ahead and change it back to that now. It would be this y secant squared xy minus 3x squared y divided by this entire quantity, x cubed minus x secant squared xy. So that's using implicit differentiation. So you see here the next example I would like to leave as a warm-up, as well as the following example on the next page. So let's leave those to do together in class this week.